Hello everyone, and welcome to the episode 1 of our beginner series on spatial network analysis. If you have ever looked at a map and wonder how Google Maps calculate the fastest route, or how city planners decide where to build a new road or a new bike lane, you're in the right place. Today we are starting with a very fundamental question. What is spatial network, or what makes a network spatial? Think about your social media network. You're connected with your friends, but it doesn't matter if they live next door to you or across the globe. The physical distance doesn't impact the connection. But in spatial networks, physical geography is very important. We build these networks using two main components. First, nodes, which represents our street intersections, and second, our edges, which represents the physical streets connecting them. The distance between these two nodes dictates how network functions. So today, we're going to be doing all of our analysis in Python using Jupyter notebooks. As you can see, a Jupyter notebook open in your screen. To make all this happen, we need to set up this environment in Jupyter Notebook. If you don't know how to set up this environment, please let us know. We'll make a video on that also. So when you have installed this setup, we need to install some libraries. So in Jupyter Notebook, you install those libraries with pip install and then the library. So today we're using three different and very important libraries: OSMNX, Network X, and oops, not here, GeoPandas. Right. Think of them like a construction crew. So they will help it build this network. So OSMNX is a library that fetch map data directly from OpenStreetMaps. NetworkX help us build mathematical graphs of nodes and edges, which are important for the network. And GeoPandas extract all the GPS coordinates and make sure that we plot everything accurately on the map. So you can install them separately or you can do them together. So I'll do it together. It says the requirements are already satisfied. It means I've already installed them together. But when you are installing it for the first time, you might see something different. So for our running example throughout the series, we're going to be using one famous street grid in the world. I mean, one of the famous one is Manhattan, New York. So we're going to use that. So we have to download and plot the street network of this neighborhood. We will try to do it very simply with just few lines of code. All right. Let's see. Before doing that, we need to import our library. So we're going to be using OSMNX, which will be our main library today. It will help us retrieve, model, analyze, and visualize, the networks directly from OpenStreetMaps. So let's import it, OSMNX as OX, and then we'll try to print to see if we have correctly loaded it. So let's just do a print statement. OSMNX version OX. This is the command to check the version of your library. Okay, it's importing, takes a while. Okay, there we go. We have this version imported. Good. All right, so now we need to define the place that we want to analyze, right? So we decided that we're going to use Manhattan, New York. So we'll use this library as a string search for OpenStreetMap so that we can get the official boundaries and everything. So let's say the place name Manhattan, New York, USA, just to make sure that we have the correct name. All right, good. Okay, now we need to download the street map for this place. We'll use the drivable network, which means that ignore the walking path, bike lanes, or service roads, and only pull the streets that are meant for cars, like where we can drive. Okay. All right. Let me see. Let me define my graph. Equals ox dot graph from place and then place. Oh, you can do the tab and then it will tell you, it can help you with the names. Yeah, here you go. Place name. And then we have to decide the network type equals, as I said, like we decided that we're just gonna download the network, drivable network where we can drive. Alrighty, it might take a while. Meanwhile, we can write our code to visualize. It is important to visualize your network to see, how it looks like. So to plot the network we just downloaded, we'll do, oh, it finishes. So let's see, figure AX equals OX dot plot our graph. Which graph? The G. We can decide the node size, but sometimes the node size looks very odd on the map, so I'm just putting it 0, but we can change it. We'll see how it looks like. And then we have the edge color to see, to check. I mean, we can choose any color. Let's just put this one. Just found it random, but we can change based on these codes. We have codes for the color. And then we have the edge width. We want to see how thick it is or how thin it is. Ideally it's 0.5, it's fine. But you can change according to your choice. That's no big deal. All right, let's see. There we go. we have this road network um, of Manhattan. Looks good. Let's try to change the node size to see where the nodes are. Let me see. I'll put 1. See, now you see all these nodes in smaller color, in white colors. They're all white color. They're all nodes, but it makes it look weird, so I'll just put it 0. All right, so here we have our network, and this is all for our first episode. And then, in the next episode, we'll move from here and then do more analysis. In the second episode, we're planning to, see how data is stored, the difference between graph data and spatial geometries. We'll inspect the data tables to view street lengths, speed limits, intersection coordinates, and we'll try to visualize the edges based on that. Thank you so much for watching, and see you in the next episode.